In this lesson, we'll be doing an activity based on the hyperbolic function or the hyperbola. So, suppose the function is given as f of x is equal to 9 over x minus 3 plus 3. The first question says, let's determine the x and the y intercepts. So, we know that for y-intercept, you must let your x be equal to 0. So we're going to say that f of x, which is equal to y, it's equal to 9 over 0 minus 3 plus 3. And let's see what we get. 9 divided by minus 3, this gives us minus 3, plus 3, and this gives us 0. This means that the y-intercept in this case is 0. Now, what about the x-intercept? For x-intercept, you let your y be equal to 0. So we're going to say that let y be equal to 0. And 0 is equal to 9 over x minus 3 plus 3. We take the positive 3 to the left side and it changes the sign. Negative 3 is equal to 9 over x minus 3. And we are going to do the cross multiplication. When we cross multiply, we're going to say negative 3 multiplied by x minus 3 is equal to 9 multiplied by 1. We multiply like this. And negative 3 times x, that gives us negative 3x. Negative 3 times negative 3, that gives us positive 9. And it's equal to 9. So, we're going to say negative 3x is equal to 9 it's equal to 9 minus 9. It's equal to 9 minus 9. And at the end, we have negative 3x is equal to 0. This means that our x-intercept is also 0. I hope it is clear. So, we must know that for the x-intercept, you let y be equal to 0. And then for y-intercept, you let your x be equal to 0. I hope that's clear. Then, write down the equations of the asymptote. So, we are going to erase here. Now they want the equations of the asymptote. Remember, a hyperbola or a hyperbolic function has two asymptotes, mainly the vertical and the horizontal asymptote. Okay, so now let's figure out the two asymptotes. The horizontal asymptote is this one. It's given as y is equal to the number that we see here. This means that y is equal to 3. That is the horizontal asymptote. And then the vertical asymptote, always when you're looking for the vertical asymptote, we must say that x minus 3 is equal to 0. So we say that x minus 3 is the number below is equal to 0. And then x is equal to 3. That is the vertical asymptote. So this is the horizontal asymptote. And this is the vertical asymptote. Well, I hope that's clear. Then 1.3. State the domain and the range. What do we know about the domain? Okay, we said that the values are not possible on the asymptotes. This means that an asymptote is a line that a graph approaches but will never touch. This means that the values of x on the graph will never be equal to 3 because they will never touch 3. So, what is the domain? We said that domain are all the possible x values that a graph might have. All the values of x are defined on the graph except where x is equal to 3. So we can say that the domain is given as x is an element of real numbers, but x is not equal to 3. I hope it's clear. So when we say x is an element of real numbers, we simply mean that the values of x are possible everywhere. All real numbers are possible. Okay? So what about the range? we're going to say that y is an element of real numbers. When we're talking about the range, we are focusing on the y values. But the values of y are not equal to 3 because we say that they don't touch the asymptote. This means that y is not equal to 3 as well. See? I hope it is clear. Then 1.4 says sketch the graph. So we're going to sketch the graph. And I'm going to erase here. And then we're going to sketch the graph. So, sketching the graph won't be a big issue. We have to add the two axes. Let's add the vertical line, which is the y axis, and then the horizontal line, that will be the x-axis. Always make sure that your drawing is to scale. It's drawn with a ruler. So here is the y-axis and here is the x-axis. So what are the two asymptotes? The asymptotes, we always represent them by dotted lines. We said that the first asymptote, which is vertical, is given as x is equal to 3, and the other asymptote, which is the horizontal, is given as y is equal to 3 as well. So we're going to say that x is equal to 3 will be somewhere here, and then we're going to show it using a sketched or a broken line. This is the vertical asymptote, given as x is equal to 3, and we have the horizontal asymptote again. So here's the horizontal asymptote, and it's going to be denoted as y is equal to 3. So what was the x-intercept? Well, do we still remember what was it? It was 0. The x and the y-intercept was 0. This means the point is here. That's where the x and the y-intercept are 0, at the origin. Okay, so it's here. And then your line will go like this. Remember, it should never touch the asymptote. It can rather go closer and closer to the asymptotes, but will never touch them. And then you can use a table method to find another point which will be in here. And make sure you write full set of coordinates. For example, let's plug 4 in the equation. We're going to say 9. We're looking for the value of y when x is equal to 4. So we're going to say that y is equal to 9 over 4 minus 3 plus 3. That gives us 9 over 4 minus 3 is 1 plus 3. And the answer there is 12. This means that the other point is given as 4 is to 12. Okay, then you will get full marks. All you have to do, you must know how to find the asymptotes. To find the horizontal asymptote, the horizontal asymptote is the one that goes from right to left or left to right. You read it here on the value of q. The one which you read on the denominator, which is here on x minus 3, is the vertical asymptote. I hope it's clear. Then they say to you, point 3 and 3 is where the two asymptotes intersect. So I'm going to use a different color to represent that. So they're saying here, that's where the point 3 and 3 is. That's where the two asymptotes intersect. Reflect the point in the x-axis. Label it point T. Remember, we have said when we are reflecting in the x-axis, the values of x remains unchanged. This means that the first point is point 1, and we are reflecting point 1 in the x-axis. This means that the x-axis becomes the mirror. And we said that the values of x remains unchanged because we are reflecting in the x-axis. The values of x remains unchanged, but the values of y changes from positive to negative. This means that the value of y here will change from positive 3 to negative 3, but the value of y will remain 3, and the point will be t. They said label the point t. This will be 3 and minus 3. I hope it's clear. So when you are reflecting in the x-axis, the values of x remain unchanged, but when you are reflecting in the y-axis, the values of y remains unchanged. Okay, so last question says, write down p of x. If p is a transformation of f. Okay, simply by transformation, they simply mean we have shifted our graph. We have shifted it. So the graph here was given as, I want to write it nicely, was given as f of x is equal to 9 over x minus 3 plus 3. Remember I said when you are going up, you add. When you are going down, you subtract. If you are going to the right, you subtract. If you are going to the left, you add. They say we are going 2 units down and 1 unit to the right. Okay, when we are talking about up and down, it has to do with the values of q, which is this one. This tells us about the vertical shifting of up and down. So because it's going 2 units down, we're going to say that f of x, we're going to do one at a time. Let's shift it down first. That will be 9 over x minus 3 plus 3. Because they are saying down, we're going to subtract 2. And then the new graph will be given as follows. That will be f of x is equal to 9 over x minus 3 plus 1. And then we are shifting it 1 unit to the right. To the right, we subtract as well. But when you're going left and right, you subtract on the x-axis. This section here tells us more about the horizontal shifting of left and right, shifting of up and down, shifting of left and right, up and down. So we're going to say that f of x, because we are transforming it, it will now become p of x, but we'll write p of x as the final answer. That will be 9 over x minus 3, and because we are going 1 unit right, we're going to subtract 1. Then we're going to say plus 1. And the resulting, they say you must write it as p of x. This means that p of x is the new transformed graph. That is 9 over x minus 3 minus 1, that's minus 4, plus 1. And that is p of x. I hope it's clear. Make sure you repeat the lesson as many times to be able to understand. This was not a question paper, but it was just a practice problem. Thank you for watching.